Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Here I will present our research about thermal comfort analysis of home living in coastal city based on physiological equivalent temperature index and operative temperature zone. This is our research. Let me introduce myself. My name is Qurrotul. I come from Sunan Ampel, Surabaya. Building thermal comfort. In recent years, the attention of the world community on this issue. And Indonesia is considered as the biggest tropical country in the world that has a problem with thermal comfort. That Indonesia, tropical country, usually has a hot and humid temperature such as Indonesia. And coastal city especially have a particular problem because of the high solar radiation and dynamic air velocity. And Surabaya become of the case study of our research that represent coastal city. And home is a human basic need that closely related with building thermal comfort. So what the specific approach of our research? An important fact in creating thermal comfort is strongly influenced by two main factors. That is thermal environment, and second is thermal balance of the human body. This point make thermal comfort varied as well. So thermal comfort approach to evaluate this research based on physiological equivalent temperature index and operative temperature zone. Talking about the method, we use simulation method in this research that happen in 24 hours. We use two programs in this research. The first is Raman Pro to analyze the thermal comfort of outdoor space, and second, we use CBA thermal comfort to analyze the thermal comfort of indoor space. This simulation use 4 subjects, that is in table 1, subject personal data. The first, we will show you about the result in our simulation program in Raman. We will go to the next slide. We will talking about PMV, predicted mean fault value. That is describing in this picture. And from this table, we can say that for resident in outdoor, second floor balconies is more cold than first floor terrace. In the same time, in same place, female subject, that is subject 2 and 4, are more feel overheated or cold at existing temperature than male subject, that is subject 1 and subject 3. And then young female subject, that is subject 3, is the most resistant people in existing temperature. That is happen during 12 hours at 6 p.m. until 6 a.m. Old female subject, that is subject 2, is the most weak people in existing temperature. That only happen in 1 hour at 6 p.m. Next, we showing you about the predicted mean fault value. The first is based on SNA. Temperature can be said to be comfortable if it is in the range of 20.5 until 27.1 degrees Celsius, with the most optimal thermal comfort temperature in 22.8 until 25.8. The thermal comfort in this house can only be felt between 6 p.m. until 9 p.m. Especially in second floor, the resident also in thermal comfort range when at 7 a.m. The most optimal comfort temperature happens at 7 p.m. in first floor and at 8 until 7 p.m. in second floor. The most overheated temperature, that is more than 40 Celsius degrees, happen at 8, 9 a.m. until 3 p.m. The change of temperature occurs significantly between 6 a.m. until 6 p.m. After we talking about the Raman simulation program, so we go to the next program, that is CBA thermal comfort. From the table, we can say that the operative temperature zone is 22.8 until 30 degrees Celsius. The living room temperature in thermal comfort situation at 8 p.m. until 6 a.m. with neutral thermal sensation. The most optimal thermal comfort temperature happened at 3 p.m. The most overheated temperature happened at 1 p.m. And the highest airspeed occurs at 2 p.m. until 6 p.m., then continue to decline until 12 p.m. and rise again until 2 p.m. Now we go to the last part of our presentation, that is conclusion. In coastal cities, especially Surabaya, home to floor is our case study in this research. We finding thermal comfort in this object. And in this research, we finding 3 main points about thermal comfort in this city. That is first about time, 2 about position, and 3 about subject. About time, thermal comfort in this city, in this place, only happen at night for 3 hours. About position, second floor is comfortable for activity about thermal comfort. And the subject, all female subject needs special attention to reach thermal comfort. So we hope that this research can make recommendation for building facade and special planning to reach thermal comfort. I will tell you that this work supported by the Ministry of Research and Technology and Nation Research and Innovation Agency of Republic Indonesia. And this is the reference. Finally, thank you for your attention in our presentation in the 20th International Conference on Sustainable Environment and Architecture. We apologize for so much mistake in our presentation. Thank you.